Hi class, how are you today? That's punny. The learning target for today is to solve for missing measures using parallel lines and proportions. For the scale, you're a 3 if you can solve for missing measures using parallel lines and proportions. 2, you can determine which parts are proportional, but have trouble after that. 1, you can use ratios and proportions to solve problems. 0, you cannot use ratios and proportions to solve problems. This will be very similar to the past few lessons we've done. It's a lot of the same stuff, just another way to use proportions to solve for missing measures. Not much is going to be new though. Let's get started. Alright, so we're going to talk about a couple theorems. First is the triangle proportionality theorem, which says, if a line is parallel to one side of a triangle and intersects the other two lines at distinct points, then it separates these sides into segments of proportional lengths. Now that's a lot. What does it mean? So say we have a triangle, A, B, C, and then we have a line that goes through it. And we say that both of these lines are parallel to each other. So if this line is named DE, then we can say that line segment AD over line segment DB is equal to line segment AE over line segment EC. So these are proportional to each other. And so if you have, say, 3 of the measures and you want to find the 4th, you just put it up in a proportion like this. Now, just as a note, the converse is also true, which means if you have a line intersecting a triangle and it intersects the sides so they're proportional, then it means that the line is parallel to the other side of the triangle. So you can use the converse as well. Also, it works as well if we have multiple parallel lines in a triangle. If we add some more parallel lines into this triangle, all the sides would be proportional to each other. Alright, let's now go on to some examples. So if we have a triangle here and I have it intersected with a line that's parallel to one of the sides of the triangles, and we have measurements 6, 9, 21, and x. So this side is 6, this is x, this is 9, this is 21. So, and we want to find what is the length of x. What does that stand for? So, if we want to solve for x, we have to set this up as a proportion. So we have 6 to x and 9 to 21. And then we cross multiply to solve the proportion. That gives us 9x equals 126, and then divide both sides by 9, and that gives us that x equals 14. So you can just set it up as a proportion and then solve. Now, in this problem, again we have a triangle cut by a line that's parallel to another side, and we're given that these two are equal to each other. Well, that'll make it easy to solve for x, because all we have to do is just set these two equal to each other and solve for x. But what about these two? We're not given any information over here except these. The thing is, if they're proportional, which they are because it's cut by a parallel line, that means if these two sides are equal to each other, then so will these two sides. So we can throw in marks that these sides are equal to each other as well. And now we can just, in the first equation, in the first two sides, set them equal, solve for x. These two, set them equal, solve for y. So that gives us 2x plus 1 equals 3x minus 5. Subtract 2x from both sides. Gives us 1 equals x minus 5. Add 5 to both sides, and that gives us 6 equals x, or x equals 6. So we know x equals 6, and then we can do the same thing to the other side. 6y minus 2 equals 3y plus 5. Subtract 3y from both sides. Gives us y minus 2, 3y minus 2 equals 5. Add 2 to both sides. Gives us 3y equals 7. Divide both sides by 3. And that'll give us y equals 7/3, or 2 1/3 if you want a mixed number. So in that case, you just solve for x and y, figuring out that if these two are congruent, then these two are going to be congruent. All right, one more example. So here we have that CB is 4, BA is 12, AE is 18, and ED is 6. And what I want you to tell me is BE parallel to CD? And this is where the converse of the theorem that I gave you comes in. If these are parallel, then these sides will be proportional. So we set it up 12 over 4 equals 18 over 6. And then reduce. If they reduce out, then we know that they're proportional. So that gives us 12 over 4 is 3, 18 over 6 is 3. So yes, they are proportional, and the lines are indeed parallel. Now time for the sponge. I want you to solve for x and the indicated measures. So in the first problem, we've got these parallel lines here, and with those parallel lines, when they intersect, they make points, A, B, C, D, E, F. So I want you to use what we just learned to solve for x, but then also find EF and AC. What are the measures of those lengths? Same for number 2, parallel lines. And I want you to find x and then find GI and IK. That's it for the lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of your notes and the sponge that was attempted. Submit it all to eBackpack, and have a good night.